Okay, good morning. So let us solve some problems related to the previous session. If you remember, we talked about three different rules in triangles. One was the area rule, and the other one was the sine rule, and the last one was the cosine rule. I just showed that why they are correct, but I didn't solve any examples for you. So I will go through some examples today, and then on Friday and next Wednesday you will get the whole session to practice, and on next Friday we will have the test, yes? And then we continue what I skipped after that, even though that will not be included in any tests, okay? So let us start with refreshing your memory a little bit about one by one. So the area rule, do you remember what was the area rule? So if I have a triangle ABC, and then it's common to denote the length of the opposite side by little a, little c, and little b correspondingly. And if I call the area S, S denotes the area of this triangle, and then it becomes equal to 1/2 the product of any two of these sides, for example B and C, but multiplied by the sine of the angle between these two sides. The angle between these two sides is A, so you can write it like this. And of course you can do this the other way around. You can write 1/2, choose another pair. For example, A and C, multiply them, and then multiply it by the sine of the angle between A and C, which is B in this case. And finally you can choose the other pair. It's 1/2 B, C, and so okay, B and A, so A and B, and then the sine of the angle between them. So it doesn't matter which one of these you use, all of them give you the area, but of course it depends to the problem that you are working on. One of them might be useful, the other one might not be useful, okay? So let me give you some exercises related to that. So this is a common practice. So let us assume that I have a circle here. Yes? And then I take the center of the circle, and I don't know, for example, I take one piece of this circle. This is called a sector, if you want to know the name, a sector of this circle. So let us assume that this angle is given to you, for example, theta degrees, yes? And then what my point is to connect these two points. I want you to calculate the area here for me. Of course, I am not solving very simple problems. Very simple problems is that, for example, I give you two sides and I give you the angle between them and I ask you to find, for example, the area. So those sort of questions are simple, yes? Let us solve some more interesting problems because I want to finalize everything for the exam this session. So we want to calculate this area. So assume that I have a circle. I give you two pieces of information. I give you this angle, 30 degrees, 15 degrees, whatever. I also give you the radius. Yes? So the number r is given, theta is given, and I want you to calculate this colored, the area of this colored region. Okay, so let us see how we can calculate that. I want to pause the video and give you a little bit of time to think about it. And then you need to find the formula, of course, for me. And then we can discuss about this. So I give you a little bit of time, okay? I pause the video now. Yes, so you might need the formula of the area of a circle. Do you have it in your memory or not? This is a very famous one. So the area of a circle is pi, the famous pi number, times the radius squared. Okay, any ideas? Just the idea, the details we can do together. But what would be the idea if you want to find the area of this red region? Yes?
Find the area of the sector.
Yes?
And then minus the area of the
Oh, that's right. So that's the idea behind it. Yes? But finding the area of the sector shouldn't be hard. For example, If theta is 90 degrees, how do you find the area of that sector with 90 degrees? Yes?
The area of the circle divided by
4. Yes? Why is that? Because 90 is a quarter of the 360 degrees. Yes? Is that understandable? So if I give you that this is 60 degrees, how do you find the area of the sector? How do you find? Yes?
Divide by 6.
Divide by 6. Because 60 is 1 over 6 of the full circle. Yes? Is that understandable? So whatever this angle is, you divide it by 360 degrees to realize what is the ratio between this and the full circle. And then you divide the area of the circle by that, you multiply the area of the circle by that ratio, yes? Now that you have theta degrees, how do you act? The same idea, here we need to work with algebra. So here I have theta degrees. What is the ratio? So can you tell me what is the area of the sector? The area of the sector. What is the area of the sector? Is equal to, what should I write?
I times radius to the power of 2 times theta divided by 360.
Yes, so theta divided by 360 and then multiplied by the area of the full circle. I just want to make sure that you understand what I'm writing. Is that understandable? So that is the area of the sector, yes? Is that understandable? If, for example, theta is 90, 90 divided by 360 is a quarter, and that is exactly what you predicted. And if theta is 60, 60 divided by 360 is 1 over 6, so it's exactly what you predicted. So that's the area of the circle, as simple as that. Yes? And now, if I ask you, can you calculate the area of this triangle? So let me call it AB. The area of the triangle OAB. What is this one? This is now the new rule, yes? Because I have given you the length of two sides, and I have given you the angle between those two sides, yes? So it becomes 1 over 2. This side OA, which is R, multiplied by this side OA, which is also R, multiplied by the sine of the angle between them. So R times R is R squared. So this becomes 1 over 2 R squared sine of theta degree. Okay, and then the area of the colored region as Dennis mentioned, is actually equal to this bigger one minus this smaller one. So this becomes theta over 360 multiplied by pi multiplied by r squared minus 1 over 2 r squared sine of theta degrees. If you want to write it a little bit nicer, you can factor 1 over 2 r squared. It is not mandatory. It's finished here. So if I factor this out, r squared is pulled out, 1 over 2 is pulled out. So what is left for me is theta multiplied by pi divided by 180. Yes? And then minus sine of theta degrees. So that would be the formula for the area, yes? So the area of the red part. For example, if you want to solve, if I give you r equals to 2 centimeters, and if I give you theta degrees equal to 60 degrees, yeah, I can ask you the same question. So the question would be 1 over 2 r squared, which is 2 to power 2, and then I would write 60 divided by 180 multiplied by pi minus sine of 60 degrees. Yes? So if you want to calculate, this is 4 times this is 2, and this one are simplified, so it becomes pi over 6. And then if you look in the table or use your calculator for calculating sine of this is this number. And then you multiply 2 inside, so it becomes pi over 3 minus the square root of 3 area units. So that's the exact value of the area of this sector if r is 2 centimeters and theta is 60 degrees. Yes, is that understandable? Okay, so let us solve one more at least example here. So for example, let us try to draw the same circle somehow. Yeah, let me clean this and draw this here again. Something like that. So now, for example, assume that this is the center. I call it O. Let me, for example, draw this line. And then I pick a point here, and then I have this. Yes. I give you this to be, for example, 5 centimeters, and from here to here I give you, for example, 12 centimeters. Hopefully these numbers that I am giving are working. And I give you this 30 degrees, and I connect this to this. Yes. And now I'm asking you to calculate this area. So let me see if the information is enough. I just randomly wrote the numbers. Hopefully this will work. But anyway, so I have a circle. This is the center of my circle. By the information given on this picture, I want you to calculate the area of this red region. So I pause the video so that you can think a little bit. Okay, any ideas? Yes? Yes, you can say.
So first you get the area of the circle,
Yes?
and then you get the area of the triangle, and then you subtract the area of the triangle.
By the circle you mean this piece or the whole circle?
The whole circle.
Okay, and then how you can use it?
Then you can use it, and you can, first off, you find out the area of the big triangle, then you subtract that from the area of the
That
circle.
part, yes?
Yeah.
Okay, that part is a sector, so you need to find the area of the sector.
Okay.
Do you understand what I mean?
Yeah. Okay. Yeah, I did it wrong then.
No, it's not completely wrong, but the area of the sector we'll learn how to calculate right now, yes? So you calculate the area of the whole circle, and then divide it by what for getting this? For the area of the sector? It is 30 divided by, so you want to calculate the ratio, yes? So here I calculate the area of the whole circle. So the area of the whole circle, the area of the whole circle is equal to pi r to the power of 2. R is 5 to the power of 2, so it is 25 pi, and then of course centimeters squared. So this is the total area of the whole circle, but you want to find the area of that sector. So what I have to do, what is the ratio of this sector to the whole, yes?
Times 30 over 300.
Yes, exactly. So the area of the circle, the area of the sector is equal to 30 divided by 360, this is the ratio, multiplied by 25 times pi. Yes? But 30 to 31 times, and this is 12 times. So the answer would be 25 pi divided by 12 centimeters squared. So that would be the area of the sector. Yes? And now I want to calculate the area of the triangle. So let me give names here. So this is A, for example. This is B, and let me call this C. So now I ask you, do you calculate the area, Carl Johan? So did you calculate that?
Yeah.
So what is the area of OAC triangle? So how do you calculate that?
The entire triangle is 21.25.
21. Okay, but how do you find it?
Oh, you use the sine rule. 1 over 2.
Yes, it's called area rule.
Area.
Yes, 1 over 2. Yes.
Times 17.
Why 17?
Because 12 plus 5.
Yeah, it is actually, it's up to you to understand. It's very simple. Because if this is a radius and it is equal to 5, this you need to understand yourself. That's the radius and it's also equal to 5. So even though 5, this one is given to you, this one is not given, it's easy to understand that this is also 5 centimeters. I have forgotten to write here. And the whole side from here to here would be, as you said, 17. Multiplied by 5, multiplied by the sine of the angle between these two sides. One side is OA, the other side is OC, and that is 30 degrees. If you use your calculator for sine of 30 degrees, you can immediately realize that this is nothing except 1 over 2. So 1 over 2 times 1 over 2 is 1 over 4. 17 times 5 is how much? Is 85. So this is 85 divided by 4 centimeters squared. And as you said, we subtract these two values to get the area of the red part, yes? So the area of the colored region is equal to the bigger one, which was, what was that? 25 pi over 12 minus 85 over 4. And then you don't need to simplify actually anything, you can just leave it like that. And if I ask you to approximate the value, then you put this number in your calculator.
Isn't it the other way around?
The other way around. Yeah, thank you, yes, thank you. This should be positive, negative. Thank you very much. Otherwise I get a negative number. Yes. So is that understandable? So this is one way to use the area rules. Other ones are actually quite simple. Let me write this question, even though this is simple. I hope that you remember what I told you about. So another example, let me write it in this form. A triangle. This is very simple, but I want you to draw your attention to the point that we discussed last time. A triangle has sides of length 10 centimeter and 11. The area is equal to 50 centimeters squared. Determine the angle between these sides. Of course, this is very, very simple, but the reason that I am giving you this example because I want to remind you about what we discussed last time. Okay, so how should we calculate this? I don't know, you can go to a scratch paper and you can just draw some rough diagram for yourself. For example, this is 10 centimeters and this is 11 centimeters. And then you are supposed to find this angle. So let me call this angle theta. This theta is missing, yes? But of course, the area is given to you. Okay, so what can you write? You can write 1 over 2, the size of this side, which is 10, multiplied by the size of this side, which is 11, multiplied by the unknown sine of the unknown angle for you. This is supposed to be equal to 50, yes? But let me simplify. This one and that one becomes 5. 5 times this is 55. Sine theta is equal to 50. And then sine theta becomes 50 over 55. And then sine theta, I simplify it by 5. It becomes 10 over 11. Do you agree? This is the sine of theta, the unknown theta. But then, in Math 1C, and of course in the previous session we discussed about this scenario. So how can I calculate theta using my calculator? So how should I calculate that? What is theta? Can you tell me? Sine inverse of theta. Thank you. So, and then please, I don't have calculator. Can you put this in the calculator to see? For example, let us keep 2 decimal points. So what is sine inverse?
65.38.
65.28. So it's a 38. 65.38. Okay. So if you want to keep 2 decimal points, it's not wrong, but it is not complete. Yes. Do you remember what I told you last time about sine? We discussed about diagrams. I told you that we have a precise God-given protractor and things like that. We were discovering something, yes? So this is not wrong, but this is not the only answer. The other answer, do you remember what was that? I don't want to go through all the discussion once more. So, but if you have this, if I give you this number and I ask you to calculate using protractor, what do? 10 over 11 is a number. You use your ruler and measure that length. So assume that this is 10 over 11 something. And then you draw a horizontal line. Then you see 2 intersection points. 2. Yes? One of them is the one that calculator gives you. Is exactly that number. But there is another one which is possible in this context. And this is this angle. Okay, but this angle is what? Is 180 minus this angle. Because by symmetry, this angle and that angle here are exactly the same. This one is provided for you by the calculator. This one, calculator does not give that one to you. But if you stop here, that's not complete. If there are 2 points, you will lose 1 point because of that. Yes? So you need to understand it yourself that there is another angle for the answer. So you should say, or, what should I write? 180 degrees minus this angle. Okay, can you also please calculate this to see what happens? So it should be 140, I don't know, 62 or something. Is that right? Yeah, okay. So that's the other angle. That's the whole point. If you don't do that, then this is not complete. Assume that this question has 2 points. If you reach up to this point, you get 1 point. If you do not provide the other answer, which is not given by the calculator, you need to have this picture in mind to be, or if you should have it in your memory. And by the way, this is acceptable in the context of a triangle, yes. The reason that this didn't appear in Math 1C, because in Math 1C we just talked about right angle triangles. And in a right angle triangle, trivially this cannot happen, yes? Yeah. So, but in a typical triangle, why not? This angle can happen. And it's important to understand it from geometrical point of view. What's the point here? The point is that, so one possibility is that this angle is an acute angle, and the other one is this. So if I want you to understand it a little bit better, so first of all, the answer is finished here. So you should say that theta is equal to 65.38. So this should provide as the answer. Or theta is equal to 114.62. So this you need to provide as the answer. So remember this for this. But if you remember, when cosine, let me talk about cosine later, okay? So here, this is something that you need to understand. But if we want to understand it in a better form, so let me turn it a little bit upside down. Assume that you have this. Yeah, let me tell you what is happening. You have 10 centimeters here. And let me, for example, have 65. For example, assume that this is 65. For example, 65.38, and this is 11. And then I connect this one to that one. If I ask you what is the area of this triangle, you would say it would be 50. But there is another scenario. Keep this length the same here. It's 10 centimeters. Let me see for more exact. Yeah, that is 10 centimeters again. But this time, the angle is this angle. Yes, so this angle is 114.62, and this is still 11. If I connect this one to that one, the area of this triangle is again 50. Yes? Okay, so this is the calculation shows that. But I want you to understand it geometrically. Can you convince me immediately why the area of these two triangles should be the same? Of course, you might say that, okay, I calculate 10 by 11 divided by 2 times sine, it becomes 50. I calculate the same thing here, it becomes 50. Yes, that's one answer. But let us understand it based on a geometrical picture. Do you remember what was the original formula for the area of the triangle? It was 1/2 of the base times the height. Yes? So let us consider the base of this one and the base of that one are the same. Do you agree? They are both 10. But if I want to draw the height, if I draw both of them on the same line, this would be the height of this triangle. This would be the height of this triangle. But I hope that you agree that they are the same. Yes? Because it is like this. You see, because this is 11, this is also 11. It seems that I have put the needle of the compass here and I have rotated that. Yes? So it means that this height is not changing. So h and h prime are the same. So this is the reason that we get two triangles. One triangle is containing an acute angle. One triangle is containing an obtuse angle. But both of them have the same height. Have the same area. The reason is that if I ask you what this number is, you would say 65.38. So this is the reason that h prime and h are the same. Yes? Because this triangle that you see here is exactly this triangle you see here. They are actually different. Yeah, they are just flipping. Yes? I am flipping this triangle and I get this one. So h prime and h has to be the same. The bases are the same, so they should have the same area. Yes? But the important thing is that whenever you want to calculate theta by sine inverse, calculator only gives you the one answer. The other answer is the supplement. Supplement means that angle minus 180 minus that angle. You need to understand. Sometimes it might be not possible to accept this, but in this context, yes, it is totally acceptable, so we have to write it down. Okay? So this is something that I just want to remind you. It's very important. Just put a star on it. If you think that you might forget it for the next week, you need to know that's important. Okay, so let us go to the cosine rule now. So let us solve some problems using the cosine. So let me remind you what was the cosine rule. So do you remember? So if I have a triangle, it is an extension of the Pythagoras theorem, actually. So if I have this, let us say this is A, this is C, this is B. if I ask you, this is not a right angle triangle. It might be a right angle triangle or not. So it's always correct that a squared is b squared plus c squared, but not finished, minus 2 times b times c times the cosine of the angle between b and c, which is a. But you can write two more versions for that, yes? You can write b squared. What is b squared? B squared is a squared plus c squared, the other two, minus 2 times a times c times the cosine of the angle between a and c, which is b. And then finally, we can write c squared is equal to the other two squares, minus 2 times a times b times the cosine of the angle between a and b. So you need to know how to read. Of course, these are given in the formula sheet, but it is important to understand how you need to write these things down. Let me immediately start with a very simple question. Okay, let us start with a very simple question. Example, in a triangle, in triangle ABC, we have this. We have AB is equal to 7 centimeters. BC is equal, if you don't mind, let me just draw a picture. It's easier to write down. So I have a triangle like this. Let me write it A, B, C. And I give you these three numbers. BC is 8, for example, centimeters. 8 and 7 and 5. All of them are expressed in centimeters. And then what I'm asking you to find the area of the triangle. We want to find the area, the exact area of the triangle. So this is a very, very important theorem, yes? Area of the triangle. So let me write S, make everything very simple. S of this triangle is missing. So this is the first time you are supposed to calculate the area, but the height is not given to you. The angles are also not given to you at all. Only the sizes of the sides are given to you. So based on this information, you should be able to find the area of the triangle. Okay, so how should we think about this problem? So let us think it step by step. If I want to, there is only one rule that we learned today about the area of the triangle, and that is the area rule. But the area rule needs two sides. That's okay. Instead of two sides, I have three sides. But it also needs one angle, which I don't have it. So it means that if I want to be able to calculate the area of the triangle, somehow I should be able to get one of these angles at least. Is that clear? Because if I have that angle, then I can use the area rule and I am done. So can you tell me now how can I find an angle? And probably you know that this is an example, but in the exam you need to distinguish it yourself. Recognize which rule is suitable for which problem. That's the hard part. Because there are three rules, so you need to do a lot of exercises to be quick at it. Okay. So, for example, can I calculate angle A? Yes, how? Using the first one, exactly. Why? Because it doesn't matter. You can calculate B, you can calculate angle C, but let us calculate angle A. Why is that? Because A, B, C are given to you. The only missing expression here is just the angle A. So it means that if I plug these numbers here, then I will be done. So then you need to call it. So here A is 8. So this is my A, this is my B, and this is my C. So I plug these numbers into the first cosine rule. So it becomes a to power 8, 8 to power 2 is equal to 5 to power 2, so let me write it in order. 7 to power 2, 5 to power 2, minus 2 times 7 times 5 times cosine of A. Yes? It's very simple now. 8 to power 2 is 64, 7 to power 2, 49, and then this is 25, and this is minus 70 cosine A. My missing piece is cosine, so let me move this to the right. It becomes positive 70 cosine A. And then here I have 49 plus 25 minus 64. So I moved this part to the right, made it positive. I kept these two on the right hand side as it is, but I moved this one to the right and made it negative. And then I calculate. So this becomes 70 cosine A. So how much is that? It's 10, yes? And then I want to find A. So cosine A is equal to 10 divided by 70. So if I simplify that, it becomes 1 over 7. Now if I ask you what is A, okay, so I need to, so that was probably a little bit beyond your knowledge, but let me remove the word exact, because I ask you to calculate the exact value. You cannot calculate the exact value right now. Okay, so let us just calculate this. Okay, so how much is that? Let us keep 1 decimal points, yes?
81.8.
81.8. Okay, so let me put approximation. So forget about, I talked about finding exact value. That is, it needs a little bit trigonometry. But let me stop here. Okay, by the way, do I need to consider another angle like sine inverse? This is, I want you to understand. Do I need to write 180 minus this one to consider another scenario? First of all, if you feel a little bit, you can see that no, there is only one triangle with the given sides. You cannot have another triangle. Yes, if I give you all the sides, there is one unique triangle with those three sides. So it is not possible to have another answer. This is understanding from geometrical point of view. Yes, why is that? Because if I want to draw this picture, I take my ruler, I draw a line with 8 centimeters, yes, and then I put the needle of the compass here, for example, and open the compass for 5 centimeters, put the needle here and draw a circle, something like that here. This radius is 5 centimeters. Then I put the needle of the compass here. This time I open it until it is 7 centimeters. Then I will actually draw another circle. They intersect at exactly one point. Then I will connect them, and that is my triangle. So there is only one possible way of having that triangle with having 3 sides given. Yes? So this is geometrical reason that there is no other answer, okay, like sine. But from trigonometry point of view, do you remember? How do you understand it from trigonometry and the unit circle, which is extremely important for you to understand? So if I have this unit circle, do you remember what I told you? Assume that you have a very precise ruler and protractor. How can I measure this angle without calculator? Assume that I have a very nice protractor and a very nice ruler. So I need to go and find 1 over 7 on which axis? Because I'm talking about cosine. Cosine was related to which one of the coordinates? Sine was related to the y coordinate, and cosine is related to the x coordinate. So what I need to do, I take my ruler. From here to here, you know it's 1 because that's the unit circle. And 1 over 7 is somewhere here, for example. This is 1 over 7. And then I go horizontally. I have 2 intersections again. I connect this one to that one. This angle is the one given by the calculator. Yes? What is the other angle? The other angle is this angle. From here to here. But the other angle, if you insist, is 360 minus 81.8 degrees. This is the other angle. Yes? But this other angle is so big that does not fit into any triangle. Yes? Even though, if I ask you find A, again you have to give me two answers if this is not geometry. If it is trigonometry, then there are two answers. Yes? One answer is the one given by the calculator. The other one is 360 minus this angle. Yes? But in the context of geometry, this is not acceptable. It's like a false root. That is a root of this equation, definitely. But that is a false root for the context of this problem that we are working in. Is that understandable? So this is why, this is a rule of thumb. You can keep it in memory. Yes? If I want to, in the context of geometry, whenever I want to calculate A, the answer provided by the calculator for cosine is the only answer. Okay? In geometry. Yes? But if I have, in geometry, if I am facing sine A equals to that, one answer is provided by the calculator. Either you should visualize this all the time, or you should have it in the memory that the other one is 180 minus the answer given by the calculator. Is that understandable? Yes? Okay. So now that I have A is this one, now I realize that A is 81.8 degrees. And now I want you to calculate the area. So, but the area is easy to calculate now, yes? The area of this triangle ABC is equal to what? 1 over 2 times 5 times 7 times sine of 81.8 degrees. And then you put this number in the calculator, you get an answer. That answer would be the area of the triangle, but not the exact value, because for exact value you should be able to calculate the exact value. So don't worry about the exact values yet. We will come to that later. Okay? Then you put, I don't want to continue. You put this and calculate this number. That would be a number that is the area of your triangle. Is that understandable? So that's a combination of the cosine rule and the area rule in one problem. Yes? Okay, so let me give you another example. Okay, so let me give you this example. Let us keep the formulas in front of you, so because I want you to think about it yourself. There is a picture given here. The picture is this. Something like that. So here is 3x plus 1. Everything is expressed in centimeters. And this angle is given to be theta degrees. And then this is x plus 2. And this is x plus 3. And then cosine of theta is given to be minus 1 over 5. And then you are supposed to find x. By the way, these examples I'm using are from this book, Heise Mathematics. Yeah, this is the higher level math for EB program, yes? Yeah, because we are using it on YouTube, it's better to reference it. So here you have a triangle. You are supposed, by this information, you are supposed to find x. So let me pause the video for a little bit so that you can think about it yourself.